Everything, every moving object, every action goes back to one thing: momentum.
I did.
It was crazy.
It was.
I know it's part of physics, but like, what kind of physics?
Linear momentum.
What's linear momentum?
Let's search it up.
Alright, we are getting ahead of ourselves. Let's get back to that after we explain the basics. This part of the video, we will explain the basics of linear momentum. In simple terms, linear momentum is defined as the product of a system's mass multiplied by its velocity. Linear momentum is expressed as P equals mv. Momentum is directly proportional to the object's mass and also its velocity. Therefore, the greater an object's mass or the greater its velocity, the greater its momentum. Momentum is a vector having the same direction as the velocity v, and the unit for momentum is kg times m meters per second. An example of momentum is a car crash.
店员已断开。
Well, that was unexpected. Let's explain what happened to that car. To expand on the concept of linear momentum, it's important to understand that momentum is a vector quantity, meaning it has both magnitude and direction. The momentum of an object is equal to its mass multiplied by its velocity. In the case of a car crash, the momentum of each car is transferred to the other car, resulting in a change in velocity and direction for both cars. The direction of the momentum is determined by the direction of the velocity of the car. Linear momentum is also a fundamental concept in physics and is used in many other areas of study, including mechanics, thermodynamics, and quantum mechanics. In addition, the concept of linear momentum is used in everyday life, such as when playing sports or driving a car. It is important to note that while a car crash is an example of linear momentum, it's also a dangerous and potentially deadly event. It's always important to drive safely and follow traffic laws to help prevent car crashes from occurring.
Flashback.
Now let's talk about the conservation of momentum. The conservation of momentum states that within some problem domain, the amount of momentum remains constant. Momentum is neither created nor destroyed, but only changed through the action of forces as described by Newton's law of motion. The equation for momentum becomes net force equals delta P divided by delta T equals m delta V divided by delta T, when Newton's second law is substituted. With the actual equation for conservation of momentum is ma VA plus mb VB equals ma UA plus mb UB, and the total energy conserved using the equation KAG plus KBD equals KAF plus KBF plus loss. Recalling that K equals 1/2 mv squared. Another important topic within momentum is that the conservation of energy, and that is when the kinetic energy before colliding is equal to the kinetic energy after colliding plus the energy lost in collision. The equation for conservation of energy began 1/2 m1 v1 plus m2 plus v2 equals m1 u1 plus m2 u2 minus loss. There are two types of collisions. Inelastic collisions, which is when energy is lost, and the deformation may be permanent, and elastic collision, which loses no energy and the deformation on collision is fully restored. The equation for elastic collision is m1v1i plus m2v2i and m1v1f plus m2v2f. And the inelastic collision formula is m1v1i plus m2v2i equals m1 plus m2 times bf.
End of flashback.
I understand it now.
Took us 2 days though.
Are you guys ready for the test? Huh?